This is a third lesson on geometry, right? And I'm beginning with the triangles again. we know the formula. We know two basic formulas. One is a formula for the area of the triangle, right? And this is a height, and that's a base. The area is going to be half of the b times h, okay? And then we also have a formula for the Pythagorean theory. This is a A, this is a B, that's a C. If it's a right triangle, then C squared equals A squared plus B squared. So everybody knows these two formulas, right? Okay. Then let's take a look at the following problem. Okay. Then if you have an equal triangle, okay, each side is 10. Okay. How do we find the area? Okay. How to find it? Yeah, find the area. No. Well, we cannot use the formula directly, right? So if you don't have any other formula in mind, then you have to find what? You have to find the h, the height. Okay. So this is the height. So you draw the line, then you find the a height. Okay. Because this is an equal triangle. Okay. So you get two right triangles here. After you draw the height, right? And then you see that what is missing here is a height. And this side is 5, this side is 10. So I think we can apply the Pythagorean theory to find the height, okay? By the Pythagorean theory, right? So h squared equals 10 squared minus 5 squared. And, you said put 25 there, right? That's 75. But I'm going to express in the following. 10 is 2 times 5, right? 5 squared. So you take a 5 squared out, and then you get a 3. It's actually 3 times 5 squared, okay? So h is going to be square root of 3 times 5 squared, and then it be square root of 3, and the square root of 5 squared is 5, so it's 5 square root of 3. So that is the height. Okay. Then the area is a base times the height. Okay, so it's going to be 25, right? Square root of 3. Now, when you do this type of problems, okay, what you should do? Okay, next step. So you got this idea, you solve the problem. Okay, I wish you will, okay, think about this and try to get the general formula by yourself if you don't have that formula, okay? Because you don't need to create new ideas to solve the problem. Suppose you have the triangle, each side is a unknown number, right? Now, if you are able to do that, nobody told you, if you're able to do this, you'll be potentially can become a mathematician, okay? So you will, just replace a specific number by arbitrary variable a. Then, okay, then apply the same idea, right? Then you find the height. So that will be, half of a squared equals a squared, right? Because this will be half of a. Then from here, you find the height. Okay. And after you combine them, it's a 1 minus a quarter is 3/4. Okay. So h is going to be square root of 3 over 4 and a, right? Then that would be square root of 3 over 2 and a. Right, so that's the height. You can also use a special right triangle to get this. Then the area is going to be half of base times height. Then once you get this general formula, you can use that and over again. Okay, that is, right? Square root of 3 divided by 4 and times the square. Okay. Even okay, this is about equilateral. Now, how about isosceles triangle? In isosceles triangle, you will use the same idea to find the area. Right? You step by step, right? Now, right? If you are able to find the area of about equilateral triangle and use the same idea, you can find the area of this isosceles triangle. You draw the line. You still get two right triangle. Okay, two right triangle. You don't know the h, and this side is 13, this side is 5. Right? So you apply the Pythagorean theory. Yes, applying the Pythagorean theory, h squared plus 5 squared equals 13 squared. Okay, so h squared equals 13 squared minus 5 squared. And if you remember, this is just, you can do the calculation, right? So 169 minus 25, and that's going to be 144, which is 12 squared. So it's going to be 12. Okay, so you got 12. Then the area is going to be half of, okay, base times height. So which is going to be 60. Okay. Then again, you will ask yourself, okay, this is a problem you did the exercise, right? Now, I say if you have a potential to be a mathematician, you don't need to ask you to do that, but you should be able to derive the formula by yourself, okay? So then you ask, how about general isosceles triangle, right? And if this side is a B, this side is B, this side is A. Okay, I can use the B here, and then this side is A. Okay, can I get the expression for the area of the triangle? No problem. Exactly the same idea. Okay, exactly the same idea. So you should have a, when you do a problem, for this specific triangle, you, without asking to get a formula, you should ask yourself this question. How about the general case, right? And how about a general isosceles triangle? Can I express the area in terms of A and B? The answer is yes. So when you divide this triangle into, actually you get two congruent right triangle. So this layer, this H, that's half of B. So you still can apply the Pythagorean theory to find the H, okay? Right? Okay, then you solve for H. Now this time, you're not able to simplify it, okay? So H is going to be like a square root. Okay. So this is my H. All right, then the area is going to be half of the B times H. And what is H? H is A squared minus B squared. So now you have a formula. If you're able to memorize it, then just use this formula over again. And doesn't matter what triangle you're getting given. You're given the triangle, for example, and this is a 5, 5, and I think 3 is good. Okay, 3, right? Then the area is going to be half of the B. B is 3, and A, A is a 5, and the B is a 3 over, 3. So then you simplify it. Okay, then you get the answer for the area. Okay, so let's simplify it. It's a little bit difficult. Right here, I can take 2 square out here, 5 square and the 2 square. and minus, sorry, 3 squared, okay? Yeah, right? So, and that is going to be 2, right? And here, 10 times 2 is, 5 times 2 is 10. 10 squared is 100. 100 minus 9, right? So that would be 91. Okay, so square root 91. 91 is a prime number, right? Is it a prime number? No. So anyway, it's not perfect square. So 81 is a perfect square. Okay, so you can apply this formula. Okay, that's your formula, right? You can use that over and over again, especially when you write a program for a computer, then we do need a formula. Okay, so when you're doing a specific problem and you think about it after you finish it, can I work on the general case, right? Now, when I draw a triangle, I have to be very careful because when I put a number, for the base, I put a 3 there. Can I put 100? The answer is no. This cannot be 100, okay? And here's a 5, here 5. The largest number I can put there is any number less than 10, because otherwise this is impossible, okay? This is impossible, okay? So I cannot just put an arbitrary number there. Yeah, this is impossible, okay? You cannot make a triangle, and when isosceles triangle, the base is 11, the two sides 5, okay? Okay. The reason is, if you go from here to here, right? If 11 miles, but if you go somewhere else first, then come here, they should have a longer distance. But the 5 plus 5 is 10. So 10 is shorter than 11. That's impossible, right? Strict lines always have a shorter length. So we have the following triangle inequality. Okay, we have a following triangle inequality. So if I have a triangle, okay, and this is A and the B and the C, and then these 3 numbers are sides of 3 sides of a triangle, if and only if A plus B greater than C, okay? B plus C greater than A, C plus A greater than B. Okay, so the reason is A plus B greater than C is that because if you go from A to B, right? Right, the distance is C, but you have to go along this straight line. But if you do not along straight line, it's longer, right? So that's why A plus B should be longer than, should be larger than C. Okay. So if I go back to the above problem, okay, this is a 5, this is a 5. Now what number should I put here? If I know n is integer, okay, what does the possible value for integer in order to make them a small special triangle? In order to make it as a triangle, right? So from here you can see that the first formula A plus B is a 5 plus 5 should be greater than n. Okay, 5 plus n should be greater than 5. N plus 5 should be greater than 5. So this last two satisfy automatically. Okay, n is positive integer, right? So all you need is make sure n is less than 10. Okay, so if n is integer, n could be 1, 2, 3, all the way to 9. So you have a 9 triangles with integer length, and 9 isosceles triangle with integer length. Okay, right? Then you will ask, well, okay, if it's not the right, then you ask yourself, right? If it's not right triangle, if it's not isosceles triangle, can I still find the area? Right? This is a pretty challenging because it's not easy to find out the height, right? It's not easy to find the height. assuming you can still draw the height h, okay? And then those two sides of triangles are not congruent, right? So it's more complicated. But does not mean you cannot solve it, okay? And if here's x, this is y, right? So you apply the Pythagorean theory to these two triangles. First of all, x plus y equals c, right? Then apply the Pythagorean theory to the triangle on the left. So x squared plus h squared equals a squared. And you apply the Pythagorean theory to the triangle on the right. So y squared plus h squared equals b squared. So if you are good in algebra, I said you're good in algebra, you are able to solve for x, y, h from this equation, okay? You can, okay? If you are good in algebra. Now you can try it at home, okay? Solve it for x, y, and h. Now, so if you can express, I'm not going to talk about it, okay? If you can express h in terms of a, b, c, okay? One can express h in terms of a, b, c. So h can be expressed in terms of a, b, c. So, all right? So you can step by step, doing scientific research. It's not like you get the general formula right away. You get a formula for the area of the equilateral triangle. Then you get a formula for area of the isosceles triangle. Then you ask yourself, what happens if the three sides are not, if it's not an isosceles triangle? In most general cases, triangle with three sides, ABC. Of course, ABC satisfies this about triangle inequality. Can I still express the area in terms of ABC? The answer is yes. So you get three equations, three unknowns, then you get, right? And then area is going to be half of the base times h, okay? So the area can also express in terms of ABC, just because here h is expressed in terms of ABC. And after you simplify it, and there was a guy in the history, right? It's called a Heron. Heron finally modify his expression, and finally he got this nice formula, right? So whereas s is going to be half of the parameter, all right? Then. All right, so this is an interesting formula, yeah. So he published the paper. Now his name is always associated with this formula. I give you this example just because someday you may have some, discovery by yourself. Okay, there's so many new stuff there, not necessarily in mathematics, but you cannot get this general formula right away. Maybe step by step, based on the previous work by some other people. But if you're not being alert to the things you see, you're not able to get this general formula. Okay, but yeah, some of you maybe can try. Okay, I already gave you the hint here. Solve the above equations and express it in terms of, this will be discussed in my advanced math class. Okay, that's why I didn't want to. But I'll give you this formula. It's pretty useful formula. You can now you can find the area for a very general triangle. Okay, very general triangle. Okay, for example, let's take a look at this triangle. Yeah, there's two problems here. Okay, so this side is 3, that's 5n, and here's n. Okay, first of all, let's determine what kind of values for n. Okay, so you can still have a triangle, and it should be integer. Okay, n should be the integer. All right, so let's take a look at this. By the triangle inequality, 3 plus 5 should be greater than n. 5 plus n should be greater than 3. Okay, n plus 3 should be greater than 5, right? The three triangle inequality. And let's simplify each of them. Here's a 8 greater than n. 5 plus n greater than 3 is okay, it's always true, right? And n plus 3 greater than 5 and greater than 2. So our conclusion is n is between 2 and 8. Since n is integer, 3, 4, 5, 6, 7. Okay, so you have this many choices for n. My question is, what among them, what is the largest area? Wow. Okay, think about that. When n equals 1, when n equals 3, you get an isosceles triangle. Right? Then when n equals 4, I think it looks like that. I'm not sure which one is larger, right? And n equals 5. Then you get an isosceles triangle again, right? So then you have a bunch of them. N equals 3, and so this is 5. This is 3. That is 6. Okay, then you keep going, and there'll be 7. Okay, so all those triangles, maybe you can quickly find the area, each of them, right? And which one has the smallest area, which one has the largest area? Okay, let's calculate them, right? Yeah, I think I need the Heron's formula only for the last two. Why? Because the first two, we already have the formula. Okay, 3, 3, 5, right? So let's look at the first one. Okay. Yeah, this is a 3, 3, 5, right? I think. Yeah. Do we have the formula somewhere? You know, we see that's important to have formula, so you don't need to repeat it over and over again. So this is our formula, right? The base, half of the base, okay, and a squared minus b squared, okay? So the area, so this, yeah, the area is going to be half of the base. Base is a 5, okay? And, okay, and a squared, so 3 squared minus half of the base. Right? Yeah, double check. Right? Half of the b, that's what I remember, right? So we go back here. You see, this is a formula, right? Half of the b, right? So b is the base. All right, good. So now use this formula. You can calculate, right? You can calculate this area, right? So what I'm going to do here, I put 2 square here, 3 square, and 2 square, and minus 5 square. Okay, I'm going to simplify 5, take 2 square out, right? That's a 4, right? And what is inside? Inside is 36, right? 6 square. Yeah, so 36 minus 25, so it'll be square root 11, okay? And so we get this, right? Then you take a look at the next one. This is the first one, right? This second one. Second one is a 355. Right? In this case, the base is 3. Here's a 5 square minus 3 over 2 square, right? Okay, again, I take 2 out, and here's 5 square minus 2 square, right? And we already did this. Again, this is a 3 over 4, 100 minus 9, that's a square root 91. Now, are you able to compare which one is larger? Okay, then the third one is a 3, 4, and 5. 3, 4, and 5. This is right triangle. Okay, this is 4 and 3 and 5. So the area is going to be just half of 3 times 4, which is 6. All right, my question is, how do you compare those two numbers? You just need to square it, okay? and clearly square, you know, 25 times 11, right? And then the other one is 9 times 91. So clearly this is a much larger, you know, 5 square 11 is less than 3 times square 91, okay? So this is much larger. Yeah, 5 times, yeah, right? Now, now for the last two, okay? Last two is a 356, 357, okay? I think the 356, 357 is harder to compare which one is larger, okay? 356, okay? Then you have to use Heron's formula to find the area, okay? Heron's formula, you find the area, and then the half of the parameter is going to be 3 plus 5 plus 6. So 8 plus 6, 14. 14 divided by 2, 7. Okay, so the area is going to be S minus A, S minus B, S minus C. Okay, so you get 7, get 4, 2, and 1. Okay, and I think it's square of 4 is 2, and then 14. So you have to use a Heron's formula, otherwise you're not able to solve this problem. And the next problem is 3 and 5 and 7. Okay, can you guess this is larger than the one with age length of 6? Or not? It's not easy to see that, right? About area. 3 plus and plus 7. Okay. So here, yeah, I think it's 15 over 2. It's not integer. Okay, it's not integer. Then the formula will be a little bit complicated. Okay, then here 15 over 2 minus 5 and the 15 over 2 minus 7. Okay. So let's simplify it. And this will be 15 minus 6, 9. 15 minus 10, 2. So 15 minus 14 is 1. Okay. So you will see it's not too bad, right? So 15 here is 3 times 5. So you have a double 5. And you have a 3 times 5 and the square of 3. Okay. So you get 15 over 4 and the square of 3. So now that's all you have. Okay. So you can compare those numbers and you decide which one is smaller, which one is larger. So all those are the irrational numbers. The question is, how do you compare irrational numbers? You square. Okay, you just square. Okay, you have how many numbers you're going to have here, right? Area, right? 5 over 4 square 11, right? The second number is going to be 3 square root 91 over 4, and then the square, then the right triangle one, right? Right? And the right triangle one. Then the other one is 2 square 14. 2 square 14, then 15 over 4 square 3. Okay? And then you have to compare all of them. Okay? You compare them, you have to square it. Okay? You have to square it. But otherwise it's harder to tell. Okay? You square it, and then you take the difference and which one large, you can tell. Okay? For example, let's compare those two. I'm very curious. And which one is large, right? And what you do is a squared. So the first one is a 4 times 14. Other one is 15 square over 4 square times 3. Okay, let's see which one is large, right? 4 times 14 minus I think it's this one is largest. The second one is large. The one on the left is large. Okay, the difference is negative. Okay, the difference is negative. Okay, and how about 6 between 6? You also squared 36 minus 4 times 14. Okay, 36. So this will be 6 will be less than that number. Okay. So it looks like this will be the largest area you're going to get. All right. So Heron's formula is important. Okay, it's useful when the three sides are not equal, or it's not an isosceles triangle. Okay. Okay. All right. So this is about the area of the triangle. Now let's take a look at some other problems, and where we, sometimes we also use a Pythagorean theory to solve the problem. Okay, so let's take a look at the following one. Okay, this is the name of this is called the rhombus, right? What is called that? Rhombus. Okay, so this is actually consists of two isosceles triangle. Okay, so you have two diagonals. Okay, so the length of the diagonal here, this is A, B, and C, and D. So AB equals, okay, AB equals 24, and then CD equals 10. Okay, can we find the area? I wanted to try first. Okay, so the length of the two diagonals are given. Okay, can you find the area of this numbers? Okay, anyone has answers? So I have two different answers we got.
My first answer wasn't correct. I'm going to do it again.
Oh, are you yo-yo?
Yeah.
Okay. I think that 120 might be correct. Okay.
Not the same.
Yeah, let's see. So take a look at it. By the symmetry of this picture, I see you just need to find the area of the triangle on the right-hand side. And this would be half, right? It's 12, right? and this is actually the height. Here the base is 10. So the area of this triangle, okay, is going to be half of 10 times 12. But you have to double it, okay? So area of the numbers is going to be double of this. So you just don't need to divide by 12, divide by 2, okay? So the area of this, okay, is going to be just double of that, 2 times, right? So this 1/2 is canceled out, just 120. Right? Just equal to 120. All right. So now, so now we are going to take a look at another problem, which is actually a kind of 3D picture. Okay. No, before I do this, let me look up a trapezoid. Okay. So I have a trapezoid. Okay. A trapezoid, by definition, 2 lines are parallel. Right? So if I divide this trapezoid into 2 triangles, if I know the top one is 5, the bottom one is 8, the area of the top one is 13 square unit. I want to find the area of the bottom one. Right? To find the area of the triangle at the bottom, what do you need? What is missing? Missing is the height, right?
Wait, so using the triangle, the small triangle at the top with the area 13, we will be able to find what the like height is.
Yeah, because this parallelogram, this trapezoid, I know the top edge is 5, the bottom edge, right? The bottom side is 8, so we also know the lenses. So that helps you out. Right? You need this information, all the information given. Yeah, we call this kind of problems two-step problems. You cannot just apply the formula to find the area directly. I think Rebecca's answer is correct.
I sent you mine.
Oh, you use a decimal one. Okay.
Wait,
So let's do some problems step by step. First of all, we have to know what is the height. The height, if you draw the vertical line, it's always the same. This length of this vertical line segment is always the same, which is the height. Okay. The area of the top, the smaller triangle, right, is going to be the base is the 5 actually, and the h is height, right? And this is going to be equal to 13. So from here, you will determine the height. Determine the height, divide by 5, okay? So once you get the height, then you can find the area of the triangle at the bottom. Okay, half of the base times the height. Okay, so the height is 13 times 2 divided by 5, and just simplify. Okay, this is I think 8 divided by 4 divided by 2 is just 4, right? Then 13 times 2, 13 times 2 times 4 is going to be 104 divided by 5. Okay? Yes, you can, it's 20.8. I'm pretty sure. Okay, it is 20.8. Okay. Now, the similar ideas, you can look at the triangle here. Okay. So, so what I'm having here is that, okay, I have this side is all equal to 1, okay, and so this is A, B, and C, okay, and D, okay. So other side, this side, well, how about, yeah, make it a little bit longer. Okay, I'm going to do okay, D, because this side is 2. Okay, find look at this picture, okay, find the area of the triangle ACD. Okay. Now, AD is not given, so you cannot even use a Heron's formula to find the area of that triangle. Okay. What you should do? Yeah, I give you 1 minute. Think about it.
Wait, is that bottom Y or is that 1?
1. It's a ABC is an equilateral triangle.
Okay.
Right, so I do get the answers from Rebecca. Actually, it's always doing good, fast. Okay, I'm going to wait for a minute. Okay, the hint is that you have to determine the height of the triangle. Okay, so those two triangles here right now, left and the right, they share the same height, right? So this H is going to be the height of, yeah, so they're both have the same height. Okay, so if you can, that's my hint. If you're able to determine the height of the equilateral triangle, then that's the same height for the other one. Okay. Then the base is 2, so 2 times. All right. Let's do this problem. All right, so first of all, we already know the area formula for the equilateral triangle, right? So the area of the triangle ABC, if you remember the formula, it's being square 3/4 times 1 square. Okay, if you use that formula, it's great, you know. Okay. Otherwise, you have to do it, and then I know the area is going to be the base times the height. Okay, so you can actually find the height. Okay. So you then from here, the height is a square 3/2. But you can find the height directly. You don't use the area. If you remember the area formula, you can use that. Actually, we got the area formula using the height. Okay. So this is equilateral triangle. This is the h, right? And that's why h squared plus 1/2 square equals 1 square. Apply the area of Pythagorean theory to this right triangle. So h squared equals 1 minus a quarter. It's going to be 3/4. So h is going to be square 3/2. Okay. So that is h. Okay. So once you get the h, then you find the area, right? So the area of the triangle, I forgot the name. Okay, ACD. Okay, is the base, okay, times the height, okay, right? Half of the base times height, and then that's going to be square 3/2. That's what Rebecca got. Cool. Right? It's a two-step problem. We use a equilateral triangle to determine the height. Once you know the height, then you can either way you can use the area if you know the formula for the area of the equilateral triangle, or you can just find the height and then use the height to find the area of the triangle. Okay. All right, so this is about triangle. So I'm going to talk about a little bit at the end. I'm going to talk about the rectangle. Well, everybody knows what the rectangle means, right? So A and the B. For the rectangle, the parameter, right, is going to be A plus B times 2. The area is going to be A times B. Okay, good. So here's a question. I think one day you will do the homework. You will get this. Okay. So we know that if A and B are the roots of the equation, okay, this equation is x squared minus 5x plus 3 equals 0. Okay. What is the area of the rectangle? Okay. Any of you know this? Okay. This is a geometric problem related to a quadratic equation, right? Have you learned the quadratic equation? How to solve quadratic equation? Okay. So I'm going to talk about quadratic equation a little bit today. But I wanted to try. Okay. So you know A and B as the roots of the equation. That means A, B are the solutions of this equation. We don't know what their solution. You may be able to solve it. Then area is going to be A times B. Then you find the value of A. So maybe you can just find the two roots first. Okay. Let's see. If anyone can quickly give me the answer, that's great. I still want you to try for 1 minute. Yeah, this is a problem from one of the homework. Maybe you were given the homework later. Yeah, somewhere. I forgot.
What does that mean by equation?
Yeah, the roots means the solutions of the equations. Okay, if yeah, a is a root of the equation means a squared minus 5a. If you substitute a for x, and then this equation holds. That's just a name as a solution, different name of the solutions. Okay. All right, so let's have a review on the quadratic equation, right? Now, if we have a quadratic equation, right, how do you, yeah, so here's a quadratic equation, x squared minus, minus 2x plus 1, right? If you are given an equation like that, how do you solve it, right? This equation can be written in the form like this. Then x minus 1 must be 0. So you only get one solution, x equals 1. So this is called the root, okay, of the equation. Okay, so if we have x squared minus 3x minus 3x plus 2 equals 0, right? And then there are a couple ways to solve this problem, find the solution to this equation, right? You can try to factor it. Okay, if you try to factor it, then you do get, yeah, this is the idea, right? Then it's a product of two terms. So either x minus 2 equals 0 or x minus 1 is 0, right? With the product is 0, right? So in the first case, you get 2 or x equals 1. So 2 and the 1 are the roots. Okay, 2 and the 1 are the roots, also called the solutions. Okay, and if you plug 2 for x, you do get 0. Okay, because 4 minus 6 plus 2 is 0. If you plug a 1 for x, you also get 0. Okay, so those are the solutions. Okay, those are the solutions, right? Now, and then in general, and this is another story, right? Suppose you are the first person studying quadratic equations. The question is, are you able to express the roots in terms of ABC, right? Just like what we did for the triangle, the area of the triangle, right? Can we express ax squared plus the roots? Yeah, express the roots in terms of A and B and C, just like express the area of the triangle in terms of the three sides, right? And the answer is yes, and I don't know who did it first. Otherwise, we will name it, right? Name after him. So we only call it the quadratic formula, okay? This is called the quadratic formula, okay? Quadratic formula says that, yes, there are two roots, and they're given by this formula, b squared minus 4ac, okay? And you can try to derive this formula by yourself, okay? If you have time, don't look at anything, okay? Just look, and then uses this formula, then you can solve all kind of quadratic equation. You get 2x squared minus 5x plus 1 equals 0. And it's otherwise very difficult to solve this equation, okay? You should have two roots here. So x equals 2 times 2 here, 2b, minus b, so it's positive 5. And then b squared is negative 5 squared minus 4ac. C is 1. So let's simplify it. It's 25 here minus 8 and divide by 4. Now 25 minus 8, So that would be, I think 17, right? I'm right? 17. Right. Yeah, 17. Okay. So you have two roots here. The first one is 5 plus the square of 17 over 4. The second one is 5 minus square of 17 over 4. Both are positive, but very, very bad number. That's an irrational number. Okay. However, if we add them together, you will get, I think, square of 17 cancelled out. It's a 5 plus 5 divided by 4, which is going to be, you know, which is going to be 5 over 2. Okay? And if you multiply them out, you also get a nice number. You're not going to get, it's a nice number, right? It's going to be 4, 5 plus square of 17 and 5 minus square of 17. So the radical will be gone because this is a 4 square. Here's a 5 square minus square of 17 square. Okay? Square of 17 square is going to be, here's 25 minus 17 is 16. Okay? So the answer here will be, it's going to be 8. So it's going to be 1/2. Okay? So why this is always true? Let's take a look at this, okay? So if a squared plus bx plus c, if it has two roots, then this will be written as x minus x1, x minus x2. So if we multiply this out, it will be x squared minus x1, x minus x2x, and plus x1x. So if we compare both sides, okay, this will be a x1 plus x2x is a x1 x2, and you will see that the sum of those two roots can be determined by this equation. You really don't need to solve the roots in order to find the sum of the roots, and that will be ax1 x2. Okay, so you don't need it. You don't need to find the roots in order to find their sum. So let's go back to the problem we have here at the very earlier, right? So x squared minus 5x plus 3, okay? X squared, yeah, let's consider x squared minus 5x plus 3 equals 0, okay? So a, b are the roots. So a times b, if a and b are roots, okay? Don't confuse it with the notation here, Steve. Then the product of two roots, here's the leading coefficient is 1, so the product of the roots is just 3, okay? And the sum of their roots is going to be 5, okay? Okay, you can see that. Okay, maybe I should use a x1 x2 because otherwise confused with the notation here. So if x1 x2 are the roots, then x1 times x2, x1 plus x2 is 5. Okay, just because a is 1, b is -5, that's why I add them together. So you don't need to even solve the equation and get to roots. And the sum of the roots will be just the coefficients in the middle. Okay, the product of the roots will be the coefficient, the last coefficient. So that's why some people can quickly solve the problem without doing any computation. Okay, so I'm stopping here. So you're going to get set of exercise And I hope you find the time to finish all of them. If you couldn't do a couple of them, you know, you don't look at the answer keys, you do all the problems, then you grade it, and redo the problems, you get wrong answers. And then you still cannot do that, and there may be 3 or 4 problems. You can discuss with your parents. Okay, most of your parents are very good. They're able to help you. Okay, as long as they have a degree in science, and they still remember. Okay, and if they graduate from high school, that's enough from China. Okay, then if they still remember it, then that can help. Okay, see you. Bye.